So welcome back everyone, and today we are going to solve another problem on data structures and algorithm. So this problem is named as two-sum problem, and it is one of the famous problem in data structures and algorithm. Has been asked in lots of interviews and lots of competitions. One of the starting problems on LeetCode as well. So let's begin the problem. You have given an array A with elements containing 2, 6, 5, 8, 11, and you have given a target element as 14. I'm repeating, you have given an array and you have given a target element. What you need to find is that you need to find two elements whose sum is equal to target element, and you need to return that element's index. This is the problem. So starting by solving this problem, what will be the brute force solution for this problem? Brute force solution will be traversing every element twice, one element, then taking that element and finding the sum is present, then taking another element, comparing sums, taking element. So this will be taking two loops. So the time complexity for this solution will be n square, big O of n square. So interviewer will not be happy with this solution, so he will say to optimize the solution. So how we are going to optimize the solution? So for optimizing the solution, we are going to use hash map. So let's begin. So what we are going to do is we are going to check every element present in the array, and we are going to find target minus a of I. If a of I is not present in the so I will be directly explaining the problem. So let's begin. From this you will understand more clearly. So we have given an array 2, 6, 5, 8, 11. This is the array, and we have the hash map as named HS. So we will check. The starting element will be 2. So target is 14. 14 minus 2. 14 minus 2 is 11. Is 12. Is 12 present in the hash map? No, 12 is not present. So we are going to put 2 in the hash map with the index 0. We are going to move ahead. Is 14 minus 6 present in the hash map? No, 14 minus 6 is not present. So we are going to put the 6. 14 minus 6, 12. 14 minus 6, 8. Is 8 present in the hash map? No, 8 is not present. So we are going to put 6. Index 1. We are going to move ahead. Is 14 minus 5 present in the hash map? 14 minus 5, 9. Is 9 present? No, 9 is not present. So we are going to put 5 in the hash map, and we are going to move ahead. Then the next element is 8. Is 14 minus 8 present in the hash map? 14 minus 8, 6. Yeah, 6 is present. So we are going to create another data structure which is array list, ARLS, and we are going to put both, which is 8, the index of 8, which is 5, which is 4, and another index which is 2 for 6, and we are going to return it. So this approach is simple. Just we need to check target minus a of I. If not present, then we are going to then we are going to put a of I in the hash map. This is the better approach. Now let's begin with the pseudocode of the problem. So we are going to create HS hash map integer HS, another hash map, another array list for putting index. Now let's begin the traversal from 0th index to n minus 1 index. The first thing we are going to write is if condition. If HS dot contains key, target minus a of I is present, then we are going to ls dot add a of I. If no, then we are going to put hs dot put the a of I and the corresponding index. This is the better approach. The time complexity for this solution will be big of n. Why big of n? Because we are traversing one time and we are putting it. I will first confirm it again. So the time complexity is not big O of n, it is big O of n log n. Log n for inserting every element in the array, and n for traversing and checking if the element is present, if the target minus I, a of I is present in the hash map or not for this. So n log n, big O of n log n will be the space time complexity, and the space complexity will be big O of n. So interviewer will not be happy with this with this solution as well. So he will say optimize it more. So you need to minimize the space complexity. So he will say I don't like this space. So he will say remove the space complexity. So after this you will come to another optimal solution, which is two-pointer approach. So let's begin with two-pointer approach. So what we are going to do in two-pointer approach is that we are going to take the array 2, 6. I will write it again. 2, 6, 5, 8, 11. This is our array, and we are going to put low pointer at 0th index and high pointer at n-1 index. That's it. Now we will check whether a of low plus a of high is equal to sum. If yes, if a of low and a of high is equal to sum, then we are going to put low pointer and high pointer in array list to return it. If no, this was the first scenario. Another scenario will be a of low plus a of high will be greater than target element. Okay, a of low plus a of high will be greater than target element. So in this scenario, we are going to move high pointer from one position to forward to a high minus minus. Okay. Third scenario, a of low plus a of high will be less than target element. If it is less than target element, then we are going to move low pointer to one position ahead. Before using this approach, you should keep in mind that the array should be sorted. If array is not sorted, sort it using any, according to the programming language you are using. For in Java, we are going to use arrays.sort method for sorting the elements. After this, at one position array will be, we will find two elements which is equal to, whose sums are equal to target element. So now let's write the pseudocode for this problem as for this solution as well. So we are going to have two pointer at 0th index and high index. After that, we are going to use while loop. If low is less than high, iterate in the loop. the first condition is if A of low plus A of high is equal to target element, then ls dot add low and ls dot add high. That's it. Again, the next scenario will be else if A low plus A of high will be greater. So if it is greater than target element, so we are going to move high pointer to one position forward using high minus minus iteration in the iteration. Else if A of low plus A of high is less than target element, then we are going to move low pointer one place ahead, low plus plus. That's it. After this, we are going to return ls. So this was the optimal solution for this problem. So what will be the time complexity? So we are traversing only one time in the array, because low pointer is coming forward and high pointer is coming backwards. At one position we will get two elements whose sum is equal to target element. In this problem the time complexity will be big of n and the space complexity will be big of 1, which is constant, and interval will be happy with this solution. So that's it for this problem. See you next time.